Okay, guys, let's go ahead and take a look at problem 41. This will be the last one we work today. So this says a 15 kilogram box is released on a 32-degree incline and accelerates down the incline at 30 meters per second squared. So right away we know that this is not going to be have equilibrium in the x direction. So when we do F equals ma, we are going to have an a, so that means we're going to have a right-hand side to this equation that's not 0. All right. Find the friction force impeding its motion. So they're using the word motion here. They're telling you that it's accelerating down the box, so that means that we're going to find kinetic friction. All right, so let's go ahead and draw this out. Step one, we're going to draw a free body diagram. We have our ramp here. It's at 32 degrees. On this ramp we have our box. We have mg acting down, we have our friction force acting back, and we have our normal force acting up. Cool. We want to go ahead and break our mg down into components. So our second free body diagram will look like this. I'm going to extend this ramp a little bit. Pretend it's the same ramp, okay? Still 32 degrees acting down, or 32 degrees here. We're going to break this mg down, ooh, it's so nice when you zoom in, isn't it, into the component acting straight down, perpendicular to the surface, and parallel to the surface. So this is going to be, remember this is 32 degrees here, this little angle is also 32 degrees. So this perpendicular component is going to be mg cosine 32, and the parallel component is going to be mg sine 32. So let's draw that out in this board over here. So mg sine 32 down is mg cosine 32, normal force acting up, friction force acting parallel to the plane there. Let's go ahead and sum our forces in the y. Some of the forces in the y, we're not moving in the y direction. We have a box at, sitting on the plane. It's not floating up. It's not moving into it. So acceleration is 0 there in the y direction. The sum of the forces, we have the normal force acting up minus mg cosine 32 acting down, and that equals 0. If we add mg cosine 32 to both sides, that means our normal force is equal to mg cosine 32. So I can write normal equals mg cosine 32. And if you hate this whole mg thing and you want to put some numbers in there, we know the mass is 15 grams. We know gravity is 9.8. So if over here you want to be like mg equals 15 kilograms times 9.8 meters per second squared, then the weight of this box in newtons is 147 newtons, which means that our normal force is 147 times the cosine of 32, which is equal to, let's do that real quick, which is equal to 124.66. All right, guys, so my board kind of ran out of battery there, so I'm not sure how the sound's going to be at this point, but I'm just going to keep going here so we can get through it. So we have our normal force is 124.66 newtons. We know that our friction is equal to mu sub k, in this case, times the normal force. So that'll be useful in a second. Let's go ahead and sum our forces in the x direction. So again, we have sum of the forces in the x direction equals mass times acceleration. Our mass is 15 kilograms. Now our acceleration is right here, 0.3 meters per second squared, which makes the right-hand side of this equation 4.5 newtons. The left-hand side, we're going to sum our forces in the x direction. I'm going to move this out of the way here. So we have mg sine 32. Well, we already said that mg was 147, so I'm going to write this as 147 sine 32 minus the friction force acting backwards, which is mu force normal. Furthermore, we know that our normal force is equal to mg cosine 32, and we already solved for it. It's right here. So I can say that this would be mu times 124.66, and I can rewrite 144 sine 32, or 147 times sine 32 as 77.9. So now we basically have a two-step equation here. We have 4.5 on the right-hand side of the equation there. We're going to subtract 77.9, which means that this is negative 124.66 mu sub k equals negative 73.4. Divide that by negative 124.66, and you get mu sub k equals 0.59. So the coefficient of static friction in this situation is 0.59. Anyway, guys, I hope that these couple videos help you understand the problems a little better, and I will see you on Monday. Don't forget to do the extra credit with finding the videos on YouTube, okay? Watch each other's videos too, because there might be something useful for you to learn in there.